Hello everyone, welcome to Savi tutorial on hydrology and irrigation engineering with the subject code 18CV63. So today we are discussing a module 1, that is hydrology part 1, and so today we are discussing the introduction to hydrology, importance of hydrology, and a global water distribution. So coming to the introduction, so what is hydrology? See, hydrology is the branch of earth science. So where hydro is in Greek word, which is derived from a Greek word which means water, and logy is a science. Okay, so hydrology is nothing but the water science. So if we can say the definition, it is the study of water or the science of water, which deals with the occurrence, distribution, and movement of water on the earth, including that on the atmosphere and below the surface of the earth. So that is a definition of hydrology. So it is nothing but you're going to study the water. So that is where the water has been occurred, and how the water has been distributed, and how the movement of water is there on the surface of the earth and below the surface of the earth. So that is the hydrology. So mainly it is deals with the, as it is concerned with the water, so it deals with the streams and lakes, rainfall, snow, ice, and so the water which is present below the earth's surface, what we can say as a groundwater. So this hydrology is concerned with water related to all those. So, and mainly it is classified into two categories, that is scientific hydrology and in engineering or applied hydrology. So in general, it is classified into surface water hydrology and the groundwater hydrology. So, and also it mainly deals with the estimation of water resources and the study of processes like precipitation, evaporation, runoff, evapotranspiration, and their interaction. So basically, so the complete hydrological cycle you're going to study. So, and also it will deals with the study of problems such as floods, drought, and also you're going to find the solution for how to overcome those problems. So that is all included in this hydrology part. And also, so as we know already, water is one of the main principal component for all the living things. So coming to the practical application, so where practically this hydrology are used. So basically in the design and operation of hydraulic structures like dams, reservoirs, and canals. So in those hydraulic structure, the design and operation of hydraulic structure, so this hydrology plays a very important role. And similarly in supplying the water and wastewater treatment and disposal, and for the irrigation, drainage, hydropower generation, flood control, navigation purpose, erosion and sediment control. So similarly like salinity control, pollution abatement, recreational use of water, fish and wildlife protection. So all these are the practical application of this hydrology. So where practically this concept of hydrology or the whatever the concepts or the theory part you're going to study, so those you're going to use it in all these various fields. So the next is the role of hydrology is basically, so whatever the various applications is there, whether it is design of hydraulic structure or design of irrigation or design of wastewater treatment plant. Okay, so the role of this hydrology is analyzing those problems, so in which are involved in these tasks, like whatever the task which is there, like whether it may be flood control, erosion control, or recreational use, or a fish life or wildlife protection. Okay, so in all those tasks, whatever the problems, wherever the problem arises, so the role of this hydrology is to analyze those problems which are involved in those tasks, and to provide a guidance for planning and management of water resources. So what this hydrology will do, so we are going to analyze the problems which are related to all those practical application, and we are going to you know uh, we are going to find a solution, so to overcome those problems, and how we can plan and manage the water resources. So that is what the role of hydrology. And coming to the hydroscience, see, hydroscience basically deals with the water of the earth and their distribution, circulation, physical and chemical properties. As we are talking about the science, it includes so physical and chemical properties and their interaction with the environment, including interaction with the living things and in practical like human beings. Okay, so basically hydroscience is nothing but the distribution, circulation, and the properties, the interaction, the physical and chemical properties and their interaction with the environment. So that is what the hydroscience. And this hydrologic knowledge is applied so to use and control water resource on the earth. So we have two main source of water like surface water and groundwater. So basically, so how we are going to use this knowledge of hydrology to to control the wastage of water, on how efficiently we can use the available water resource on the earth. So next, coming to the next topic, that is the scope of hydrology. So which is nothing but so where practically we are going to use, as I've already mentioned. So as we know, the water is one of the most valuable natural resource and which is essential for human, animal life, industry, and for agriculture. So we are using for various purposes, and also it is used for power generation, also navigation, and to protect the fisheries. And it also has a very, very tremendous importance in the development and management of water resource, especially for the irrigation purpose, and also for the domestic water supply, flood control, as we have already discussed, and waterlogging problem, salinity problem, okay, etc. So all these are the different scope of hydrology. So the next, you have the global water resources. See, for a proper, like if you want to manage water in a proper way, in a systematic way, so first of all you should know what is the available quantity of water. Okay, so throughout the world, what is the availability of water resources? So for that, this global water resources, knowing about the water availability throughout the world is very essential. So basically, as you know, the world ocean covers about 3/4 of the Earth's surface, and also, so the world's total water resource is estimated to about 1.36 into 10 per 8 million hectare meter. So in that total water resource, 70.3% is about salt water, and only 2.7% is of fresh water, as you see here in the figure. So in this, ocean water or salt water is around 97%, and fresh water is about only 2.7%. Okay, and again this fresh water is subclassified into groundwater, rivers, atmosphere water, or lakes and ice. Okay, so these like 0.75 is a groundwater, 0.001% is a river, and atmosphere is very less atmospheric water like water vapors. So it is 0.0001%, and lakes is around 0.17%, ice is about 2.065%. Okay, so as I told, salt water is 97%, and in that fresh water is about only 2.7%. So under that, fresh water is again subclassified into polar ice caps, groundwater, soil and soil moisture, lakes and reservoirs, atmosphere, and rivers and stream, as you see in the picture also. Okay, so polar ice is around 77%, and groundwater is around 22%, lakes is around 0.35, atmosphere is around 0.04, and rivers is around 0.01%. Okay, so these are the water distribution of this fresh water and the salt water. So throughout the world, if you take the freshwater devices, freshwater resources like groundwater, rivers, and atmospheric water, and the ice caps. So this is the water distribution. So in terms of volume and also in terms of percentages throughout the world, like glaciers is around 24,000 into 10 per 6. So it is in the power of 10 per 6. Okay, 24 into 10 per 6 meter cube, and groundwater is around 4,000 into 10 per 6 meter cube. And similarly, you have for lakes, soil moisture, atmospheric water, river. So totally it is around 28253.2. So into 10 per 6 meter cube. Okay, so which carries around 100%. So this is a worldwide distribution of freshwater resources, and so this is again globally the distribution of water. And coming to the Indian water resources, so in India, how much water resource is available? So India covers around 329 million hectares of geographical area. So where it contains a very large river basin. So where that large river basin is divided into 12 major river basin and 48 medium river basins. Where 12 major river basins has an area catchment area of about 252.8 million hectare, and medium river basin is around 24.9 million hectare, and the total annual average runoff of the rivers of the world, it is around 4%, and more than 80 to 90% of the runoff. So in this 4%, more than 90% of annual runoff so occurs during a monsoon months. And also, so in India, the annual precipitation is estimated about 4,000 kilometer cube, that is including snow. And but as per the assessment of CWC, that is Central Water Commission, and uh, both surface and groundwater, the average annual runoff is around 2,333 kilometer cube. So according to this CWC, so the annual runoff, average annual runoff is around 2,333 kilometer cube. So which includes both surface water and the groundwater. And also, so average annual potential of water. So average annual potential of water available in India is around 1869 kilometer cube. So in this 1869, so only 11123 kilometer cube of water is available for the beneficial use. So water potential is around 1869 kilometer cube, but in that, so which is available for beneficial use is only 1123 kilometer cube. And also the per capita availability of an natural runoff so is only 2200 kilometer cube per year. So that is 1/3 that of USA and Japan. So only 1/3 of that whatever USA and Japan is used. So we are the per capita availability of water is required. And also the per capita water availability decreases with the increase in population. So as the population increases, the per capita water availability so will go on decreases. And also, so in India, so the estimated per capita demand is so in 1951 it is around 6620 meter cube. That is a per capita demand. So the available per capita demand, it was in 1951 it was 6620 meter cube. In 71 it was 4349, and in 81 it was 2829. In 2000 it was 2384. So it is estimated for 2050 it will be 1589. So as you see here, so as per the time, so the per capita demand is decreasing. As population increases, the per capita demand decreases. As you see here, as we move on, so with respect to the time, the per capita demand decreases. So, and the reduction of forest, okay, reduction of average annual rainfall and average per capita demand. So rainfall, the reduction of forest is one of the major reasons so for this decrease in the per capita demand. So there will be obviously, if the forest reduces, obviously the rainfall is going to reduce, and which reduces, in turn reduces the per capita demand. So, and this is a tabular column which shows the surface water potential of India, especially. So river basin, we have 5 river basin, that is water flowing rivers like rivers of Kerala, Tamil Nadu, Tapi basin and Narmada basin. So the water potential in terms of million meter cube, it is around 30547 1.3 million meter cube. And from the east flowing rivers, so from the east flowing rivers, that is Kaveri basin, Mahanadi, Ganga, Godavari, Krishna, Pennar, and between Kaveri and Pennar, so it is around 3,555.9.5 million meter cube. And in Indus basin, so it is around 79470.1 million meter cube. And in Ganga basin, so it is around, that is, it includes Chambal, Yamuna, and Ramganga, Gomati, Ghagra, and main Ganga basin. So this rivers includes around 55,082.7 million meter cube of water potential. Similarly, Brahmaputra and Baraka basin includes 590713.6 water potential. So this is the surface water, because these are all the river basins. Okay, surface water potential of India. Okay, and so coming to the groundwater potential in India, so about 2/3 of the total land area will be comprises of consolidated formation, where it can deposit a water. Okay, and remaining 1/3 is about unconsolidated and consolidated formation like alluvial tracts. So the area in which the groundwater potential is available in India is like springs in the Himalayan highlands and freshwater sediments of Kashmir Valley and Indo-Gangetic alluvium and Malabar and Coromandel coastal areas and tertiary sediments of Kaveri Delta. So these are the areas where the groundwater potential is available in India. Okay, and also the National Commission on Agriculture, that is in 1976, so they have estimated the groundwater resources at 350 kilometer cube. So okay, so they have estimated the groundwater potential to be 350 kilometer cube. So out of which only 260 kilometer cube was available for irrigation. So only 260 kilometer cube so is available for irrigation. And the groundwater exploitation committee, so in 1979 they have suggested a suitable methodology for estimation of groundwater resources. So and also using the norms of CGWD, that is Central Groundwater Board, in 1955, so they have estimated the groundwater potential so of India to be 431.89 kilometer cube. So this is the groundwater potential of India. And so here, so this particular two tables shows the state-wise fresh groundwater resources. So that is with respect to different states, and this is with respect to different river basins. Okay, the first table shows with respect to different states, so what is the availability of groundwater resources in India. Similarly, so the second table shows the river basin, the basin wise the groundwater potential so in various in India. So that is according to CGWD in 1985. So they have provided so this particular data. So thank you. So these are the reference books for this particular subject. And the next topic, so we'll just continue in the next class. Thank you once again.